So now it's my pleasure to introduce Cameron Westcamp. She is the operations manager at the University of Idaho, Rinker Rock Creek Ranch. Here you go, Cameron.
Do I have to press any? Oh, it's on. Okay, good. You can hear me. Thanks for joining us. I'm just going to say a brief introduction, and then I'm going to turn things over to our speakers. Just wanted to say welcome. This event is part of our outreach series called Sagebrush Saturdays that we do several times throughout the summer. We're trying a new format this year where we've invited some guest speakers to speak on Friday evening here at the Town Center West with the library as our partner, and then we'll have an event tomorrow. You can come out to the ranch tomorrow from 10 to noon. Come out to Rinker Rock Creek Ranch and join us for a little walking tour of some of the beaver dams and the beaver dam-like structures that we have on the property. And Eric Winford, one of our speakers, will be leading that tomorrow. So you can meet us tomorrow out at Rock Creek Ranch. We're going to meet at the East Fork kiosk. If you need directions, let me know, or you can look on our website. We've got a flyer posted there as well. So just wanted to make sure you're all aware of that. And I'm going to quickly turn things over now to our speakers. Our first speaker is Ed Galindo, and he is the CEO of the North American Native Research and Education Foundation. And following him will be Eric Winford, who is the Associate Director of the University of Idaho's Rangeland Center. So thanks for being here, and take it away.
So we're here. It's Friday. Our planet's kind of warm, but that's what happens for the 4 days of summer in Idaho. It becomes warm like that. I need the 2K girls up here before you get too far back. Kimai. That's the Shoshone word for come here. Yeah, right here, facing the audience. And so tonight we're going to talk about beavers. That's what I'm here for. But we're going to talk about cross-cultural education. And so I'm going to talk about indigenous tribes, specifically Shoshone-Bannock tribe. That's near and dear to my heart, and 20 plus years, and have relations on that tribe. And so it's customary when the K girls, I ask them a question if they're going to provide coffee, because I knew it was going to be hot in here, and they hemmed and hawed and said no, there's plenty good coffee shops in Hailey. And then one of them, I think it was Kay, I got my fancy pickup that come through, oh, you have an email, so I hid it when I was driving. Oh yeah, we can bring coffee if you want, but I couldn't imagine a hot cup of coffee right now. I don't know what you guys are thinking. So that's one thing. I mean, it's so nice of them going to give, but I have a gift for them. And from Fort Hall, it's equivalent to my sister in Fort Hall made these, one for you and one for you. And thank you for doing good things for this community. Yeah,
very nice.
Now, there is another one in here, Professor Eric. But since I'm old, I forgot his gift right now. But I got his mailing address in my sacred lab book, so I won't forget it. So yours is coming, Eric. Okay. Also, one of the K girls are going to be a stickler for my timekeeper. And when I have 5 minutes left, I'm going to wrap this up because I don't want to infringe on the good professor's time with his fancy slideshows. I was... for many years, the science teacher on the Shoshone-Bannock Indian Reservation, and so that's what I was doing there. And so I have some notes here that I wanted to do, and then keep in my 20-minute time frame because I'm a stickler for time. So I'll start. So thanks for the share time today. I'm Ed Galindo. I'm a Yaqui Indian that has taught science at the Shoshone Senior High School on Shoshone-Bannock Reservation, an all-Indian high school, an all-Indian school for many years. I went on to graduate school as a NASA fellow, completed my PhD at Utah State in science education and physics. Currently, as was mentioned, I'm CEO of the North American Native Research Foundation. And our goal is, this is a tricky phrase, took me a long time to come up with this, raising dollars for Native scholars. Did you get that? Oh, man. Kate, this is going to be a rough crowd here. I can just see tonight. Anyway, so far, the North American Native Research, that's a mouthful, it's called NANRAF. Acronyms NANRAF. NANRAF, we assisted 12 graduating American Indian scholars, PhDs in the STEM field. And we have another 12 in the queue. And so I tell my own students, you know, you're supposed to, if I help you, you got to help somebody else. And they go, just one? I go, no, two. Because I did 24. You know, you could do two. And so if that happens, their action should continue. And they're so far doing their part. So those 12 are assisting the other two, and those 12 will do, and you can do the math on them out. But today I'm here to talk about beavers. I was trained to live trap and transport Latin, Castor candidus, beaver, common name. I had Shoshone Elder as my instructor, Mr. Laverne Bronco, which we're going to talk about this set up here in a minute. I want to share what I know about different nations that have different concepts of things. First of all, right up front, you should not be here if we're on a native reservation. I had to ask permission to do this. We don't tell stories in the summer. Can you imagine why that's a rule within Native people? Any guesses? Oh, the suspense is killing me. Because you should be working. You should be as busy as a beaver, pardon the pun. And if you're gathering berries and hunting and gathering wood, you're getting ready. So you're busy. It's not story time. Story time's in the wintertime. And that's why I started out with my good guest here at sitting in a chair, because that's where you'd be in a big sagebrush campfire right here. We'd be in a big teepee. And the storyteller would be me, would be in this chair right here. So now I'm in a podium, and it's summer, and I shouldn't be here to begin with. So it's kind of an interesting thing. But so I told the elders I was going to go there, and they go, what? They go, don't those... And so a non-native person is called Taibo, which is you're light-skinned. Don't they know that there's no stories? I says, no. How are they going to know that unless I tell them? I say, oh, yeah, okay, so you can do that. But traditionally, we shouldn't be doing that. But it's such a good tale, I just can't help myself. And if you have questions, kind of keep them to the end, and you can ask Professor Eric and I together so I don't infringe on his time. Okay, but anyway. Beaver's name in Shoshone Bannock's Hene. They go by other names when they plug irrigation culverts or irrigation ditches, but I can't share those with this good crowd, what they call them. They get pretty mad. They're sacred animals of the tribe. There's another beaver family on our planet called Euro-Asian beaver, Latin name Castor fiber. They are two different species. The North American beaver, Castor candidus, has 48 chromosomes. The European beaver has 40. The human and chimpanzees are separated by 2 chromosomes. So they wouldn't think that we're the same species as our chimpanzees cousins, because we're not. And these beavers aren't the same either. There's a wide genetic variance in there. We are tied together, beavers and humans, by many things. One thing is curiosity. Now I'm going to do a science demo for you. Oh, this is so much fun. You know, here we go. Oh, before I forget, I have cards here, and these are my. When you're in the academic world, you trade cards like baseball trading cards. You know, you put them in here. Help yourself, and they're good. I try to put enough oil in them. You can light them if you get lost around here, and there'll be a big fire. So anyway, help yourself. But we're going to do something here, and I want you to listen. Because I'm not showing slides like a good professor. I'm not going to name names right with Eric isn't here. But so I'm going to do, you got to use your imagination. You ready? Listen. Is anybody curious about that that's in this room right now? Anybody at all? Yeah. Let me see your hand. Oh, you little beavers. Yeah. A beaver, would be curious about this as well. But they're really curious if they have a dam and you dig a channel out and you set up a big old trap, live trap for them, and that water's running. They don't like that noise. It sounds like this to them. This, by the way, is a water hammer. It's under partial pressure. What would happen if water was under full pressure? Okay. What not? Oh, no. If you're in a space capsule and you go out that space suit, your blood boils within about 10 seconds. And so if this was under full pressure, it'd be boiling. It'd be boiling hydrogen and oxygen off. That's why fish have gills, because there's oxygen in the water. They can capture the oxygen. But it's partial pressure. It's not a full pressure, because you would see a boiling sign. So don't get tricked by that, saying it's full pressure, because it's not. But it's a partial pressure. Now, where do these water hammers happen besides me standing up here doing it for you? Have any idea? Has anybody built a new home ever? Yeah, I hadn't either, but anyway, if you're in a home, maybe a new building like this, and you hear this, that's kind of bad news, because the water is in those lines, and it's slamming against the soldering of the next fitting that it's hearing. It's doing this, because water has mass, and you put it under pressure and speed, and it'll bust a pipe. And so you want to be sure you bleed out all those lines before you start your new home. If you're a beaver, you don't worry about that, because you're surrounded by water all the time. But beavers don't like running water, because they're curious. They go, what the heck is that? So they'll come up. They will. They'll see what's happening, and I put some goodies in this trap for them. They're curious about that, and they'll step on the pan, and a big trap will hold them like this. Not to kill them, but live trap them. Why would we do that, do you think? Yeah, you guys are killing me here. Because we want to capture them, because something's happened. And I'll get to that part of the story. Two-eyed seeing. That's another reason you're here. That was on the flyer. Two-eyed seeing. Two-eyed seeing is a concept, a form of knowing and learning. I learned this from a Canadian Mi'kmaq elder named Albert Marshall. He's in Canada, by the way. His gift is multiple perspectives. Learning to see life with one eye, with indigenous ways, and the other eye, the strength of Western science, and finding that intersection in between. Now, two-eyed seeing applied to beaver by us, Mr. Marshall, if I could add one thing. 2 ears listening. Many people don't listen. They don't. I don't know why. Because you're all going at the speed of light those little gizmos have. You're going fast. But listening is real important. So if you don't see things, you don't hear things, you miss a lot of things, right? So two-eyed seeing. For example, when a beaver family plugs an irrigation culvert, many folks just want to kill the beaver family. I've seen them shotgunned. I've seen them shot with a rifle, with a pistol. Many sad ways. But another way is to install a beaver deceiver or beaver baffler. Don't get these mixed up. We'd be here for days. And not even Professor Eric could get in here. If this does not work, then we can live trap them and move them. It's risky. Because what if I live trapped you and moved you? Let's say to New York City. And some of you probably are from New York City when I say that all the time. But if you weren't, how would you survive? If you're by yourself, 50-50 chance. If your family member is with you, 30, 70 chance. So when you trap beavers, you bring the whole family, because everybody's together, everybody's a unit. So then you build ways to do that. So trapping, you don't always have to kill to solve a problem. You don't. You really don't. I use students to help educate themselves and others about this process. 2 eyes seeing, 2 ears listening. Beavers are known as a keystone species. That means what they do when they build a home affects many other plants and animals. For example, When beavers build a dam, the water level raises up, and this helps the riparian zone on the stream's edge, so grasses and plants start to grow. Helps trees and bank shrubs start to grow, which helps cool the water for the fish populations. Next, the ponds provide a food source for larger animals like deer, elk, and moose. The ponds provide a refuge for some animals to escape wildfires that aren't as fast as a deer or a moose, that travel kind of slow, like a turtle. Be a nice place, a pond. Oh, and the trees help capture CO2 and decrease nitrogen, which helps with the climate change question that we're dealing with. Finally, the beaver ponds help to filter and clean water, recharge the aquifer. They're sacred animals for the tribe because of all the good it does. Other animals do good work as well. For example, bees, the pollinators of our food. Because they're doing that, we survive as a species. Without them, it's kind of hard. I want to talk a little bit about now. I want you to go back in time in your mind, because I don't have fancy slides, not to mention anybody in here, but we're going to go back to Benjamin Franklin. Oh, that was a guy. He was a character. And he was hanging around this native who happened to be an Odaga, which is with the Iroquois nation, spokesperson, named Casanego. And he was interested not only in what Casanego thought, but how he was thinking. And it was through Casanego that part of our Constitution came to be, because of the 5 tribes uniting and the 5 United States uniting. Same type of concept like that. So I want to read. So there's this Treaty of Lancaster in 1744. And these characters in Virginia said, we want this treaty with these natives. We'll send some of their sons, no women, by the way, to our colleges, William and Mary College. Has anybody been to William and Mary College? Yeah, I was there too as a guest. You see a guy like Thomas Jefferson walking around reading the Constitution, and he's dressed up in the garb. It's kind of a funny place. But anyway, they said during these treaty negotiations, I'm going to read you this, so I want you to listen. 2 years listening. During treaty negotiations, the Virginia legislature offered to send 6 Indian youth to school in Williamsburg at the College of William and Mary. Casanego declined the offer, saying, "We know you highly esteemed kind of learning taught in these colleges, and the maintenance of our young men with you would be very expensive to you. We are convinced, therefore, that you mean to do us good by your proposal. And we thank you heartedly. But you who are so wise must know that different nations have different concepts of things, and you will therefore not take it amiss if our idea of this kind of education happens to be not the same with yours. We've had some experience with it." Remember, this is 1744. Had some experience. Several of our young people were formerly brought up in colleges of the northern provinces. They were instructed in all your sciences. But when they came back to us, back to the tribe, they were bad runners, ignorant of every means of living in the woods, unable to bear the cold or hunger, nor knew how to build a cabin, take a deer, or kill an enemy. They spoke our language imperfectly. They were therefore neither fit for hunters, warriors, or counselors. They were totally good for nothing. We are, however, not less obliged by your kind offer, though we declined accepting it, and to show our grateful sense of it, if the gentlemen of Virginia shall send us 12 of their sons, we will take great care of their education, instruct them in all we know, and make men of them. So see, there's different thoughts. And if I take 2023 minus 1744, it's 279 years have passed. Have we had 2 years listening? Yeah. Got you. How much time do I have, Kate? Oh, just fine. Does anybody have a birthday in here? Anybody? Is it your birthday today? No. Is it today? No. Oh, okay. Because there's somebody that I can't mention. Maybe be there. So anyway, 5 minutes left. Yes. I think that's mainly what I wanted to talk to you about, other than, I'm here to talk about beavers, but I'm here to talk about cultures. And, there's really not a right and wrong way. There's a gray way of doing things. And so why I'm telling you a story would make Native people scratch their heads about what's happening here. But once they understood that you don't know anything about what we're doing here, okay. But if you ask me next year at the same time when I'm sweating up here and it's hot, then it's going to say, I don't know if they had 2 years listening or not. It's better for wintertime. I think that's it. I want you to think about beavers as environmental allies, not a critter to destroy. If you can think of that way, then you're 2 eyes seeing, 2 ears listening, and we have a wonderful ally. Not that they can solve all the problems, they can't. And some beavers that cause trouble, they have to be maybe put down. It's very few cases. But they can be transplanted, do some good work somewhere else. I'm going to quit there. Oh, other than one last thing, I'm going to be biased. See this little paper here in the chair? I got some comments there. On number 2, how would you rate this topic? Now, this is my mom over here. If you make me look bad, my mom, I got to go 2 hours with looking bad. Maybe excellent might be good, for that. Number 2 was the most, what's the best, the most interesting aspect of this program? Hopefully it's 2 eyes seeing and 2 ears listening and water hammer. Huh, Eric, Professor Eric? I'm done. Thank you very much for your attention. We are ready for Professor Eric to come up here.
Did that get loaded up? Oh, she's doing it up there. Yeah, that should be the one. There you go.
Don't forget there's cards there, and you know what to do with them, but they're there. And then if you want to see the beaver, by the way, this is a beaver pelt from 1906 from down in Nevada way. It's a long story, but I ran out of my 20 minutes. So if you want to see it.
I'm just pulling this up, so go ahead and tell the story if you like.
Well, there was a rancher there. He knew I did beaver. He said, I want to talk to you. He said, I trapped beaver because that's what I did back. And that's what my grandfather did for something to do on the ranch.
It's up there.
And he says, now I know that we didn't have to do that, but I took good care of the hide. I want you to have that. So it comes from northern mountains of Nevada. Pretty good hide. Those holes is where the ears were, and you can take a look at that too. Okay, Professor, I'm out of here. Sorry.
All right. Well, thank you so much, Ed.
Thank you, Professor.
Well, I hate to correct you, but I'm not actually a professor.
Oh, you are in my eyes, Eric.
I am working on my PhD, but I don't have it yet. But
you will. Don't worry about that.
Yeah, we'll cross my fingers. I'll tell you next year, maybe.
Yeah, you'll get there.
Thanks. Thanks for joining us. My name is Eric Winford. I'm the Associate Director of the University of Idaho Rangeland Center. I'm out of Boise. And before you think this is a bait and switch topic about why is someone who's got rangeland in their title and works in rangelands talking about streams and beavers, it's not a bait and switch. It's actually very important. The water in our arid landscapes in Idaho is about 53% rangelands, by the way. It's super important for everything. So, of course, we all know water is essential for life. But especially in arid lands, all the vegetation that we have out here is water limited, which means that the vegetation that we see, the vegetation that's expressed in the landscape, is totally dependent on the water that's available. So we might have sagebrush in some areas, moving to grass, moving to willows, all based upon water gradients. And we want that water on the landscape. And so that's kind of why my title is starting out the idea of slow water, because we want to keep our water on the landscape as long as we can. And we're learning a lot from beavers. As Ed has mentioned, and is a pioneer, that beavers can teach us a lot. And they can teach us a lot about how to slow down water. Because despite their name, these structures, we call them beaver dams, well, it's a bad word because they're not actually dams. They're actually very, very leaky structures. They're very porous. Water goes through them, goes around the edges, goes over the top, goes underneath them. Beavers build kind of ways to get around them through there too because they have to move upstream and downstream. I'll mention fish later, but yeah, these are actually very porous structures. They're not very dam-like. And so why do we like these structures? Why do we like beavers? Why are we talking about it? And Ed has mentioned this a little bit. In beaver meadows, water slows down. And when it slows down, it can spread out. It deposits sediments rich in organic material, and that helps shrubs and grasses and willows grow. And you can kind of see that on this little dam here. It's a pretty small dam. That's probably only like 8 inches tall or so. And it's spreading out all that water up to those willows over there, all that way, just that little 8-inch structure. And that slow water will also infiltrate into the soils. It'll replenish the groundwater, and it'll reduce peak flow in the high water season and kind of extend that season of flow. Ultimately, we're talking about why slow water allows these greater connections in this watershed. So the flood waters will get, when there's a flood, as you saw this spring, a lot of these, we went out and visited a lot of beaver meadows, and the water was just flowing all over the meadow. It was just flowing out of the stream, out into the floodplain. And that allows the water to slow down when it reaches out into that floodplain, and that'll like slowly soak into the soil and then move downstream. And that really increases the productivity of those meadows and actually increases the carbon sequestration. In beaver meadows compared to areas that don't have beaver meadows, the carbon in those beaver meadows is much, much greater. So these can be a technique maybe for reversing and storing some carbon. And for fish, beaver structures are really, really good. They create a lot of different types of habitat. They create deep pools where fish can hang out in when it's hot. They create kind of riffles as dams are abandoned and sediment fills in behind the dams. Those create kind of riffles, and so those are pretty good for rearing structures. And again, it's not very seldomly are dams actually a barrier to most fish. They can kind of jump over structures or go through them if they're going downstream. And if there are large dams, and there are some large dams, they stake around for a little while. They may blow out. They fill up with sediment. So they're not if they are a barrier for a little bit, we have seen dams that are maybe 6 feet tall or more. So that would probably be too big for a fish to jump over. But those dams don't stick around for very long. So they're not a barrier for a long time. So the other thing I want to talk about is, that's the idea of slow water, slowing water down, letting it soak into the ground. It's not fast water, so it's good to compare, kind of get a sense of contrast here. Fast water, when I talk about fast water, I'm talking about water that has no impediments. It has a lot of force, it has a lot of power, it can pick up a lot of sediment, and it moves fast, and it goes down through this channel, and it starts incising down. And you can imagine that this stream right down here, this is probably 4 feet deep, used to be up in this meadow and used to be flooding out over that meadow and depositing its sediments and like infiltrating into the ground. But it's been concentrated for some reason. We don't really know why, but it's been concentrated. And that concentration has given it more force, just like Ed's water hammer example. And that force is just cutting through the sediment. And this is another way it can show itself as fast water can show itself is through head cuts. This is a little meadow over in Rock Creek where the water is concentrated, and as it concentrated, it kind of started pushing over a little lip. And then that lip led to a drop in water, and falling water has a lot of power. And so that creates more erosive force. And as that water erodes, it exposes roots all along the edge. and those roots dry out once they're exposed to air. Roots like soil, roots like to be in soil. Even if it's drier soil, they want to be in soil where there's tiny little pores of water available. Once they hit air and exposed to air, they'll dry out and they'll die. And then that meadow starts like just unraveling, almost unzipping. You can stand there year after year and you can look at these meadows with head cuts and you can see them slowly advance up the meadow and start eroding. So on the other side, so we've seen fast water, a couple examples of fast water and what that is. On the other side is just stopped water. You know, ponds, dams, those have their place, but that's not what we're talking about here. You know, those are important for livestock and for irrigation, but it's not what I'm talking about when I'm talking about slowing water down. So let's talk about how we can do this slow water. And we've learned a lot from beavers, and the easiest step is just to let beavers do it. This is a structure on Rock Creek, and they built this in a season. It was like over just a couple of months in the summer. It was just amazing to see how fast they put that up. And that's probably one of those 6-foot tall dams. And as Ed mentioned, we can learn to live with beavers. And that's the other part of my conversation that I really want to hit home, is that we live in a landscape that's pretty altered right now. We've put a lot of structures, a lot of infrastructure in our watershed. Roads, bridges, culverts, irrigation ditches. And those things don't play well with beavers in some ways. Beavers like to build dams. This is an example of a dam right against the edge of a road. And they're building that dam up, and then the beavers are doing what they're doing. No, blaming the beavers, but the road was in there. And that road is almost about to get washed away from that rising water. And so how do you deal with that? How do you coexist with beavers? So there are ways, and Ed mentioned some. This one actually has a little pipe. You can't really see it maybe in the photo, but there's a stake over there on the far left side of that, and there's a pipe by that stake that goes underneath the beaver dam. And so it's a pond leveler. And so it's helping to drain that pond or keep that pond at a certain level. There's actually going to be a talk here in this venue on August 8th on more about how to coexist with beavers. So if you're in the area, come back. It's supposed to be, I think it's going to be really, really good. They'll dive into more detail with it, but like I just wanted to hit on this and say that there are ways that we can live with beavers. So if you see beavers and you have a beaver, great, and we can figure out ways to live with them. There's also those areas that don't currently have beavers, but maybe we can reintroduce them. And this is a structure, and this is a little beaver right there. We built this structure, and then just like a week later, I came back and I noticed that beaver was swimming up through it. And that's a little starter home, beaver starter home. I think Ed was calling them beaver helpers. Or beaver dam analogs, that's another word for them. Because they are trying to act like a pond. That is starting to slow water up and pond it up to a couple of feet deep so that the beaver can use it for hiding. And it can maybe it'll take over. It actually didn't take over this site, but that's fine. They have choices. But you can use it for hiding. So that was really good. And that's one way to help get beavers started, is to build these little starter homes for them and then reintroduce them into areas, into streams that are suitable for them. This is another area that they would love to have beaver, and we are hoping to reintroduce beaver in this area. But if you notice, I mean, there's sagebrush right along the edges of this stream and a juniper right there. There's not a willow in sight. And so that beaver wouldn't have anything to eat. And so they built these structures. These aren't necessarily built as beaver dam analogs or beaver helpers, but they're built to kind of help slow down the water, help expand the area that water can interact with on the edges of the stream. And then willows will start growing on the edge over time. Sediment will start depositing. That area will be much better for willows. And I've gone back to the site, and you can see the dead sagebrush along the edges of the stream. And they have planted willow along the edges of the stream, and that's reestablished. So maybe in a couple of years, when that willow gets tall enough, they can reintroduce beaver in that area, and the beaver can take that spot over and do with what they need to do. And there's other areas that just aren't suitable for beaver. You know, maybe it's because the stream doesn't have enough water in it. This is a small stream. It goes intermittent it went intermittent 2 years ago, and it'll probably probably dry up again this year. There's some areas that just might not be good for beavers because of closeness, proximity to infrastructure, or other things that don't do well with beavers. And so in those cases, you can do similar, do a similar type of structure. This is not, and this structure is just kind of meant to slow the water down again, allow it to capture some sediment behind it, and then that sediment will help build up a bank out of this inside stream. We'll start getting, ideally, some plants establishing along the edges that are dry land species that aren't sagebrush, but are more like willows. And then that over time, this stream will function more like a wet meadow. This is another example of a similar kind of structure meant to kind of capture water, slow it down, spread it out. You can see it's slowing water down, it's spreading it out on the edges of the stream there, and it's got a little drop there, maybe just like 4 inches or 5 inches right there. That will allow the water behind it to drop all that sediment out behind it. And there's other structures too that we've learned from beavers that basically act to help streams meander around. And a stream meander is a way for a stream to slow itself down, lose some power, but still continue downstream. And these structures are basically just built on the edges of the stream bank, and they push the stream to one side. And what that does is that allows the outside edge of that stream is moving faster than the inside edge. And the inside edge then starts slowing down, it starts depositing sediment. And the outside edge keeps going, and it actually will start eroding a little bit on this outer bank. And so it's a pattern of deposition on the inside and erosion on the outside that starts creating a meander pattern. And that's a very important pattern to see in streams. And it's very helpful, and it's very important for plants to establish there, because they'll use the newly deposited sediment on the inner bank there to start growing. And they need a lot of willows and grasses and sedges really like that fresh silt and sand that's very wet and close to the stream still. So here's a sequence of photos that we did where we built some of these structures on the upper left in a stream. And this is one year after they were built. And we built them on the stream, and we built them about halfway to 2/3 across the stream. And when they pushed the stream to the outside edge, and then all this gravel and silt deposited between the structures. And then the next year after that, look at that, all the grasses and forbs started building up and grabbing onto that newly deposited sediment, until you get more and more of it started to establish. And you can't see it very well in there, but there was actually some willows establishing, some tiny little willows establishing there, until you get to this spring, and that's what that looks like, where it actually withstood a pretty high flow. There's a little bit of erosion right there, and then the rest of the structure held up intact, and because of all those roots that were establishing, held all that soil together. And those roots are just so important for the health of the stream and for the health of the whole ecosystem. So, what's my time looking like? Yeah, about 5 minutes. Okay, I'm going to wrap up here. So, what is this all trying to do when we talk about slowing water down? There's a number of benefits that we can start listing. Ultimately, we're trying to re-wet the landscape, and re-wet the West is a phrase that my friend Josh has used before in a couple of instances there when he's talking about this practice. And this is actually a creek nearby. This is Baugh Creek. There's a little structure down there that was built 3 or 4 years ago. And this is at a high flow. This is this spring, but you can just see it's like all that water is spreading out in that floodplain, and it's depositing that sediment. It's not incising. It's moving along pretty good just because of the high flow, but it's going to create such great habitat in there for fish, and hopefully beaver will start taking over that site too. That's our goal. And when we do this slowing down the water, it's going to benefit, sage grouse, because sage grouse like those little edges of the meadows, and they like the forbs and the insects that live right there on the edges of the meadows. Those are super important for sage grouse survival. And it's going to help the moose. The moose need that cover. They need those big willows to hang out in, and then they eat a ton of willows all the time. And it's going to help our watersheds, because the water, it's going to hopefully improve our drought resiliency, because that water will be soaking into the meadows, slowly moving downstream, not rushing downstream, but just kind of slowly moving downstream and giving us all these benefits. And then it's going to just help us. I wanted to put this quote here by Aldo Leopold, one of my favorite conservation thinkers. And the Sand County Almanac, if you haven't read it, go across the street to the library and pick it up. It's a great book. I read it all the time. Every time I read it, I get something new out of it. But I like his quote a thing is right when it tends to preserve the integrity, stability, and beauty of the biotic community. And I think that's such powerful words, is to think about that. And like integrity, stability, and beauty of the biotic community. It's so interesting here. And these camas lilies right there, they're beautiful. It's a great shot, but it's also kind of important to note that those are important for a wide variety of reasons. It's not just a pretty view. It's not just a pretty flower. It's very important culturally. And so these areas, these meadows, these streams, they're very important culturally to everyone. And so, it's not just wildlife that'll benefit for it. It's not just, drought resiliency that'll benefit from slowing down water. It's all of us. And I want to do some thanks here right now. None of this would have been possible without a lot of people in front of me. As they say, I stand on the shoulders of giants. There's a lot of folks from Utah State University, Joe Wheaton, who's kind of thought about a lot of this and put in some of those first structures that we had on the ranch. And then funding support from Natural Resource Conservation Service, the U.S. Fish and Wildlife Service, the Nature Conservancy, the Wood River Land Trust in Blaine County. And yep, that's my email if you ever want to reach out and chat. But appreciate it, and thank you all for your time. I think we got a little bit of time for some questions here. If anyone has questions. Do we assume our position up here, Ed, where we can be queried? Okay. I'll sit down here. Thank you.
That would be good.
I think this question is probably for Eric. What's the physics of a stream that's starved of sediments from a dam or a road that's narrowed the channel, and then it erodes more because it's starved of sediment? What's the physics of that?
Whew, yeah.
This one doesn't work?
Oh, you got the question? Yeah. So what's the physics behind a stream that's starved of sediment? We should take a class, really. And then we can go into a lot of the numbers that go into the equations behind that. But the simplest way to explain it is that a stream has at a certain power is going to have a certain erosive force. And it's going to pick up sediment with that erosive force up to the point where it can't carry any more sediment. And then it starts dropping that sediment out. But if it's got a certain amount of power, it's going to erode somewhere. And so if you have a stream and its sediment and it's starved to sediment. When it goes downstream from that, it will start eroding more on additional banks because it has more capacity, you know. So there's I guess that's a way to think about it. There's the capacity of the stream to hold sediment and its force. It's a simplified answer, but yeah.
Ed, we just learned that your microphone isn't working for some reason, so.
He turned it off.
Oh!
That's why, because I wasn't speaking anymore.
I was just wondering, do you see with spring runoff, do you see beaver dams collapsing and washing away, or are they typically built pretty strong to handle
Okay.
the spring snow?
What was the question?
If during high spring runoff, like this spring, do you see a lot of beaver dams collapse?
Yeah, you do, but you see something else happen. Beavers have their young, and then the young stay around for 2 or 3 years. And not because they're afraid to go out there in the world, but they have a job. It's help raise up their siblings. Well, what's mom and dad doing, the big beavers? They're the ones building the big dams, like you're talking about. And so remember the sound of that water? They don't like that. So they can get it right on it, fix it, dam it up, the most aggressive stream we've ever seen. The younger ones, by the way, are helping find feed for the younger ones, protecting the younger ones. And then after about 3 years, they go off and find their mate. So it's a really in-tune system of beaver and stream. And I want to make a comment on Eric's other question. The other word you're looking for is R, resistance. So as the stream goes down without resistance, it goes faster, as fast as it can. And it'll cut a gorge down. It needs resistance, like a rock or like a beaver analog or like a beaver dam. That's resistance for water, which slows it down. Another way of looking at that is friction. Our feet have friction, otherwise we'd skirt around the planet like crazy. But so resistance is the other part of that equation that Eric was talking about.
And to add on to what Ed was saying, we see sometimes, rarely you'll see like a catastrophic dam explode, like dam just break, but a lot of times they're built really well. Yeah. What'll happen, they'll move around, they'll scour an outside edge. They'll just kind of rise up and they'll start cutting away at a bank on the edge, and then the stream just kind of starts going that way. And then the dam's still intact, but it's just the stream is moving around it in a new spot. And that can actually be really good. That's like a part of the dynamic cycle of streams. That's actually something that we're looking for.
So one other point on Eric's slide, because he has a fancy machine to give you pictures for his story, is that there's an elder told me this, and by golly, I believe it's true, that beavers taught the salmon how to jump. So they're in those streams, like Eric said, at the bottom, and then when it's time for them to get out, they get out. Pew! And so beavers have a pretty good role. Trout can get out too. I mean, Eric brought up a good point. They're not cement dams, and the beavers don't go to the local authorities, ask how much concrete they can use or get permission. They just do it, and it's all natural mud and sticks, and it's meant to not last forever. So it's porous. So if there's fish in there, they can get out, especially because I work with salmon as well. That's another story. But beavers taught the salmon how to jump. Okay. Did that answer your question, or did we go off kilter on that? Kind of did a little bit.
Anybody else with a question?
Yeah.
Sure.
Well, yeah. Oh, good. You have one. Go ahead.
So this maybe that's for both of you.
Okay.
What's something you see with public perception on beavers that is incorrect, or that you would like to correct?
Yeah. Well, two things. I'll go first, and I'll let Eric, correct my messes here. So one thing is that beaver's a nuisance animal that we have to kill it. That's not all the way correct there. Yeah, maybe it's nuisance when it gets your tractor stuck in your hayfield. You may think it's a nuisance, but it's just doing this job, making a living, and you're trying to do your job. That's one thing. The other thing is beavers are herbivores. They don't eat fish. Another concept, well, the beaver's eating all my trout. No, they're not. They don't eat meat, you know. Now, there's an exception to that when you catch them, and I've caught them, and then there's a series of tests we've done, including eating hair samples for DNA, and I instruct students how to do it safely because they have big teeth, and they're scared. And if they see something, there's a good chance they're going to clomp down on it. If your finger's round and brown and fat like this, it looks like a stick, you know, and they don't mean to, but they're going to cramp down, so you have to watch out for the teeth. So they're really not aggressive. They're not trying to hurt you. They don't eat meat, and they don't have to be killed is one thing I've heard of the public. How about you, Eric?
I think it's just the extent that beavers are, that this landscape used to have beavers.
Oh, yeah, that's a good point.
There was we have sort of a cultural amnesia of our history, and 200, 250 years ago, this whole area was just like rampant with beavers, and then it was trapped. Like they were all trapped out. There was a fur war to remove all the beavers from the greater Oregon territory, so Oregon, Idaho, Washington, between England, the Northwest Hudson Bay Trading Company, and the American fur trapping companies. They were basically at war with each other, and they were like, we're going to trap all the beavers out of this land so the other company doesn't have any of them. Yeah. And once those beavers were removed, well, we set in motion just a cascade of events that we don't really comprehend. Like we have the best information we have is old stories. Some diaries from the first pioneers who came through, and if you read those diaries, every stream was just like they complained about how hard it was to wade through all the willows to get across streams, and how many beavers they saw.
I have a question for this group. Are you ready? For anybody. What do you call a bear with no teeth? Give up? It's called a gummy bear. Ah, dang. Eric, this is a rough crowd,
It's Friday, I don't know.
I just can't believe you guys, give me a break. It's a STEM joke, it's in nature. About Eric's point about beavers, not only were they here, but in places like Southern California, ancient beavers, and they found this out by doing soil samples, and there's this probe that goes down deep, 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 and they found logs were laying not natural, but like this. Something was a giant beaver, estimated the size of a small brown bear, but over 600 pounds, easy. Put those logs and built a lot of these big meadows and big valleys that we have in our landscape today came from ancient beavers. I mean, and then they went away. The University of Montana has a replica of a nice beaver. I took a picture, but I didn't show pictures today. But anyway, about this huge animal called a beaver, and the tail was more pointed. It wasn't flat like the modern day beaver, but still, nonetheless, big teeth, taking down trees and laying them and making meadows that we use today. Besides the beaver, Eric was exactly right. Besides beaver wars and making President Lincoln hats out of the furs, because once those beavers are gone, they're gone, and now we're just now catching up. So there's another question I have for you guys, unless you have a question for us. If it's going to be dead air, I have tons of questions for you guys. Yeah.
I have a question. So maybe 20 years ago, I interviewed a rancher in the Camas Prairie. I was doing a program on beaver and contrasting Lewis and Clark's experience with contemporary people's experience. And so I got directed to this gentleman, and he said that he grew up on this ranch, and when he was a child, there were beaver in the streams coming down, but that there had been some sort of either state or federal program to trap out the beavers because the beaver they were doing bad things to the land. What this gentleman told, and so they were all gone. And what this gentleman told me was that at a certain point, they saw the error of their ways and started reintroducing beaver. It sounded like it was maybe like 20, 25 years ago. And so I guess my question is, have there been previous efforts, and have they been successful? And if they have, great. If they haven't, how does what you folks are talking about gonna move that whole process, continue to move that whole process along?
I'm so happy you asked that question, because another obstacle for beaver to get over are cows. And this ranch you're going to go to has about, what did you tell me, 300 head of cows? And if cows left to their devices love to live in a stream, they love to get on the bank and lay in the bank. It's just their nature. But this ranch isn't going to do that because they know about that. Buffalo, on the other hand, they cross and they go, and they're on the migration route all the time. They're not laying around because predators eat them if they do that. So they're on the move versus cows. Cows are different. And so there are ways to fence out riparian zones and access single access so cows can drink water, because they need water as well, but they don't need the whole stream to lay in, because they can do so much damage to a stream that you're trying to get built. And they're just being a cow. I mean, I'm sure they don't have a mean intent to make damage, but they like to make holes and they like to rub in them, especially big bulls. Oh man, those guys, they're just hilarious. But anyway, there is a balance you can do, and this ranch is a great example of that, with cows and beaver, and people and beaver. And that's the U of I, hats off to U of I for having a place like this, because you as a public have a vested interest. I mean, it's all of our dollars collectively that fund these land grant universities like we're talking about. And you can ask questions and you can see what happens. The U of I team, they're great managers. They watch out, the best they can for a lot of different things. But that's one thing you may see on your walk is how cows look at streams. And they look at things different than you and I'll tell you that. Anyway, I just wanted to mention that you said that about cows. So
I'd love to read more about what you found.
Oh, yeah.
Or hear more about
it.
But
I kind of digressed a bunch. So in 1948, the Forest Service captured a bunch of beavers in this state, and they put parachutes on them, put them in place, and they kicked them out of the highest streams around here. And they came down. A few of the beavers gnawed through their cages before they were getting close to ground, and they perished. A few crashed and had a crash landing and perished, but many of them landed, gnawed out through the wooden crate that they had, and were established in these high countries that would take eons to get there. Live weight beaver I caught in the town of Pocatello was 115 pounds live weight. The trap wouldn't almost not close. And it was an urban beaver, and it had an attitude because dogs were after it, and it was ready to fight, the minute that happened. And it really didn't like it when I had to get a rectal swab on it. It didn't like that at all. If you get beavers and you got to get a rectal swab, I'm telling you that, they're not going to like that at all. And they'll let you know they don't like that at all. But anyway, there has been those attempts, but it's much better to, like Professor Eric's talking about, have a plan. Now, I'm telling you the truth. You may have a plan, and you may have fancy slides of where the beavers are going to go, and they may say, we don't like this place at all. And I put beavers in places that I thought they would like, and I swear that aliens come and took them out, because I couldn't find them. They went upstream or downstream at lightning speed, and they have a mind of their own. That's why it's important when you transplant beavers, you have to have a mindset of the community, because they may go to places they're not wanted. And if that happens, you get another call. And so you need to have, a mindset. This is an experiment. We're trying this out. If they cause troubles, there's many things you can do. You can put netting around it. You can put deceivers, bafflers, these pipes. There's many things that you can do besides just kill them, and then live trap them, of course, to move them out. So.
Yeah, there've been a number of efforts before, and you know, maybe history repeats itself and maybe it just rhymes with itself, but what we're trying to do is learn from what has happened before and then just continue to expand that. And I think one of the biggest expansions in my mind is what is the community.
That's it.
You know, it's why we're here today, you know, is to expand the idea that beavers and similar structures can help to slow the water, and why that's an important thing. And hopefully that will start growing on its own and continue the work, so that, you know, there's going to be some locations where we can restore beaver too, and that's going to be great. And there'll be a lot of locations where it's not going to be suitable, but there's a lot of other work that we can do out there.
There's also other homes you can take them if they're not suitable for that home. There's other homes that want them. Any other questions from you elitists that live in Hailey, Idaho? What a beautiful place, you know. It is. It's very, very pretty around here. You guys live in a good place. Any other questions? Don't get me started on gummy bear jokes anymore, please.
I'm going to have to remember that.
One per group only, you know.
Well, thank you.
Is that it?
So if
Don't
there,
forget, come look at the water hammer if you want to, and this carcass and a card if you want to get that. It's right here.
so I just want to thank you both so much for a really interesting and lively conversation, and really thank the Rinker Rock Creek Ranch for approaching us about offering these talks. So thank you all very, very much for
Thanks
coming.
for having us.
Thank you.
Great.
Thank you, Professor.
Yeah, thanks, Ed.